but it is used in more scenarios in combination with other directions. And when using, the meaning is not the same as using it alone. For example, if I want to make an ACL now, I want them both to be online. I will define two addresses here later. Let both hosts go online at the same time. Now if I want to match the traffic of the two of them, should I use a basic ACL or an advanced ACL? For example, now I want it to access 8.8. But for us as everyday users, I want to go online. Whether it is 8.8 or 9.9 or 10.10. No matter how much. Internally there are now two hosts. But there may be a dozen in the future. 20. Or 30 hosts. I can't do an exact match. It cannot be said that if you do route broadband, you only let it access this 8.8. Access to 7.7 does not work. Can you make a limit to its purpose? Including the future to limit it to a port. For example, only let it access port 80 of 8.8. What if it does not open this port? For the Internet, we act freely. Can do anything. So now you just need obtain the traffic of the host users who belong to the Internet and want to go online. Just let it out. So we use the basic ACL on the line. Then we start to configure. We need to do the corresponding configuration on the gateway. Access list. Let's just enter a 10. Permit any. Let's let all the hosts below go online. In fact, you can also enter 192.168.1.0 here. 0.0.0.255. This is okay. So now it's just a matter of grabbing this traffic. As long as you configure ACL, ACL can get these traffic. So, get them online. Please pay attention. For this permit, if ACL is used alone, permit means to allow. And when this permit is used in NAT, it means grab. For the experiment we just did, means the data comes in. Whether to allow normal traffic forwarding now. It is an allowed concept. But here it means fetch. That is, match the data. In the future, as long as ACL is combined with other directions, e.g. policy routing, when combined with them, permit means to grab. It is used to capture traffic. The specific execution actions and strategies are completed by other tools, rather than being done by the ACL itself. So its binding ability is very strong. It's more like an extensible tool. Combine with anything. Now the intranet host has done this. We will make an address on the public network later. IP NAT. We are here to define a public network address pool. Call it NAT. Let's type a question mark to see what it is. There is a start IP address here. Let's assume that starting from 100.1.1.3. Enter another question mark. Let's assume end from 100.1.1.4. I give it two addresses. There is going to be a mask here. Mask is 24 bits. I have now created an address pool. There are two public addresses in the address pool. Start and end. If this input point 5 is 3 addresses, I just configured an ACL. This ACL is used to match the addresses of these devices that can access the Internet. Then I will now have multiple hosts on the Internet. Match multiple addresses on the Internet. I'm going to combine them. Remember that basic command we just had? IP NAT inside the source. This command is what you must enter no matter what configuration. List 10. It is the 10 we just defined. Pool NAT. This NAT is the definition we just made. This is an address fixed format. List 10. This is the multiple PCs we just grabbed. Pool is our public network address. So we now put these PCs inside. Map to this external public network address pool. Let's ask these two PCs to ping 8.8.8.8. This PC also goes to ping 8.8.8.8. Now both of them can go online, because they now have multiple public addresses. We don't actually use it much at work. If you're interested, let's get to know each other privately. We mainly look at the configuration. Okay. Now I'm going to reboot the device. Let's do the most used command now. This is the most important. We just defined too many things. So now need to reboot. We do not need to do any configuration on this switch today. We open it. Now let's talk about the last mode of NAT. The last one is the one we use most now, called PAT. P means port. We now use more port conversion. That is, port and address translation. There is still a circle. But this circle is different from what I just wrote. There is only one address in this circle. It has only one 200.10.10.1. But it corresponds to a different port. And this picture is like this. This is a 10.1. This is a 10.2. Here are two addresses. This PAT is an address. But the difference behind is the port. For the form of PAT, network address port translation is allowed. Multiple internal private network addresses now. Different ports map to the same public network address. This is a concept of it. Allow mapping like this. This is what we use now. An external public network address. Multiple internal hosts use one address, but using a different port. That is, modify both the address and the port. Because for the port, its overall range of variation will be greater. I said before, there are 65,535 ports in total. Let me tell you about the number of ports. That is to say, we actually use this form now, whether at home or at work. In fact, this is the way. Multiple hosts. Address and port conversion at the same time. So let's take a look at how it communicates now. Now internal host A is 1.1. When it visits host C in the future, it will have a local random high port, greater than 1024. For us now, it locally takes its own address plus a high port. Go to port 80 of 100.1.1.1. Prove that it is accessing its HTTP service. When it is accessing, there will be a public network address at the exit. 200.10.10.1. When the data goes out, it will send port 1025 originally from the address 192.168.1.1. Convert to port 2843 of such a public network address. Then the destination IP and port remain unchanged. Sent to host C. After the host receives it here, swap source IP and destination IP. Swap source port and destination port. Reply traffic to port 2843 of such an address. When the device now receives the data from the public network, when it accesses the local port 2843, then it checks the mapping table just converted. It will convert this data back to port 1025 of 192.168.1.1, which is equivalent to the variables in it except the address. Actually added the port. Then you will find, due to different ports, we can then distinguish traffic from different PCs. Even if the internal host B generates the port starting with 1025. No problem. Because the ports that may be generated by the two hosts are the same. But when the future is converted, the external port will never be the same. Because there will be some port records on the device. Will be stored in the mapping table. Now this port has been used for port 1025 of internal host A. Then in the future other devices want to go online. Also use its address, but with its different port. When we record in the device, is to take the address plus port,